All right, so the next type of factoring we're going to do is not optional. This is mandatory, and it's kind of my I don't say kind of. This is my favorite factoring. I don't know why. I really enjoy these. So again, we're going to start with the answer. This is a factored difference of squares. And what you'll notice is that it's two brackets that are identical but with different signs. So x plus 3, x minus 3, 3x minus 4, 3x plus 4. And what we have to do is figure out what's the question going to be that's going to give me these factored answers that are the same brackets with different signs. So let's multiply them out. So if I multiply x plus 3 times x minus 3, maybe you remember this from chapter 4, I would get x squared, and then maybe you skip out the middle term because you know they cancel out, or maybe you don't. So x times x is x squared, x times negative 3 is negative 3x, 3 times x is 3x, and then 3 times negative 3 is negative 9. Like I was saying, those middle terms go away, and I'm left with x squared minus 9, which we're going to call a difference of squares. It's a binomial with a minus sign between it, and both of the terms are perfect squares, right? Same thing here. If I was to multiply this out, I would get 9x squared, and then the middle term would give me 12x, but then also a minus 12x, and then negative 4 times 4 is negative 16. Middle terms cancel out. I'm left with a difference of squares. Okay, so it's a binomial, minus sign between them. They're both perfect squares. Now, both of these, hopefully you remember your perfect squares from the last video. Okay, so 9, 16, and 1 are all perfect squares. But we have to take a second to talk about the powers. These are x squared, so it's pretty easy to tell that they're a square. But you're going to come across some other exponents as well that are also perfect squares. So let's square some different powers. So this is x to the 1 all squared, which would give me x squared. This is x squared all squared, which would be x to the 4. X cubed all squared would give me x to the 6. And x to the 4 all squared would give me x to the 8. What we're going to be looking at is that these are perfect squares because the square root of them is perfect. So the square root of x squared is x. The square root of x to the 4 is x squared. Square root of x to the 6 is x cubed. And square root of x to the 8 is x to the 4. What did we do to take the square root? Well, we divided all the exponents by 2. So that's how I recognize a power is a perfect square. The exponent is divisible by 2. And I write it like that instead of saying it's even because I want you to think about the fact that to take a square root, you divide the exponent by 2. So let's look at these 4 examples and determine whether they are differences of squares or not. So we're looking for, first off, are they binomials? Yes. Second off, are they separated by minus signs? Yes, yes, no, yes. Last off, are the two terms perfect squares? In other words, are the numbers from that list of numbers we know, and are the exponents divisible by 2? So 81 x to the 4, 36 y to the 6, all good. 9, good. X to the 3. Nope. That's odd, right? That's not a perfect square. What about this one? 36 is a perfect square, even, even. 9 is a perfect square, even, even. So this one is a difference of squares, and this one is a difference of squares. The two middle ones are not. Now let's look at how we go from these difference of squares back to this factored form. Well, it's a pretty easy process. Step number 1, always greatest common factor first. Isn't one. Move on to step 2. Step 2 is to draw your brackets, just like your perfect square trinomials, except for this one, instead of 1 squared, you just draw 2. Then one of the brackets gets a plus and one of them gets a minus. Doesn't matter which one. Then lastly, take the square root of the first term and write it first. And then take the square root of the last term and write it second. That is it. That is the only way to factor a difference of squares. So let's look at these 4 examples. First one, p squared minus 100. It's a difference of 2 perfect squares. So I'm going to draw my brackets. One gets a plus, one gets a minus. Square root of p squared is p. Square root of 100 is 10. Always check to see if you can factor further. My hint that I'm done is that these are linear factors, meaning my exponent is a 1. So unless there's a greatest common factor, it's definitely done. All right, let's try this one. Greatest common factor? Nope. Difference of squares? Yes. Draw your 2 brackets. One gets a plus, one gets a minus. Square root of 9a squared is 3a. Square root of 25b squared is 5b. That's it. It's nice, hey? These last two have some tricks in them. So what about this one? Is this a difference of two perfect squares? No. So what can I do? Well, let's greatest common factor out of 2. Take a 2 out, write it out front. I'm left with x squared minus 9. Now I'm left with a difference of squares. Plus, minus, square root of x squared is x. Square root of 9 is 3. Awesome. So when you're looking at this question on a test, this would be a 2-mark question because you had the greatest common factor and difference of squares. These ones would be 1-mark questions. So just keeping that in mind, it's always good to kind of look at the expectation of a question and how much work it should entail. So I'm going to tell you right off the bat, this is a 2-mark question. Factor it. Give it a go. Okay, in other words, I hope you pause the video. So I hope you recognize that it's a difference of squares. So I'm going to draw 2 brackets. One's going to get a plus, one's going to get a minus. Square root of y to the 4. So remember, when you're taking a square root, you divide the exponent by 2. So I get y squared in each of my brackets. And then the square root of 16 is 4. What? Why am I not done? Can anyone see it? This is still a difference of squares. So it's a 2-mark question, and I have to factor using a difference of squares twice. So all I would do is keep this first bracket the same. This one's not factorable because it's not a difference of squares, so we call this prime. But then this one, I can factor to drawing 2 brackets. One gets a plus, one gets a minus. Square root of y squared is y. Square root of 4 is 2. Now these are linear factors with no greatest common factor, so it's good, right? And then this one is a sum of squares, so it's done. That is your 2-mark question. All right, go give those a go.